Let's have a closer look at the new Audi RS Q e-tron today. Audi started to design this new Dakar Rally competitor in summer 2020, and there are a lot of design features to talk about. We will have a closer look at the drivetrain first and talk about packaging and aerodynamics afterwards. Audi was looking for a new motorsport challenge where they can show their competence for future drivetrains, including using their own battery. That's something that Formula E and other categories cannot offer. So the Dakar Rally offers the perfect stage for Audi to design a race car from scratch with relatively little restrictions. As a big manufacturer, it was obvious that they wouldn't compete with the combustion-only drivetrain, and an electric race car was their wish. But since race cars have to cover more than 800 kilometers per day doing the Dakar in race conditions, an electric-only drivetrain wasn't the answer. So they decided to use a combustion engine as range extender. Advantage of this concept is that the combustion engine can run at one defined speed and can be fine-tuned at exactly that point. So the engine can run much more efficiently than a revving engine. So Audi decided to use components that they already had in their shelves. 3 electric motors, the same as they used in Formula E, one at the front axle, one at the rear, and one connected to the ICE crankshaft as a generator. Then they designed a new 50 kWh battery, which weighs 370 kg, and installed a 295-liter petrol tank. To give you an idea of how much energy both hold, take a look at this. Audi then decided to use their 2-liter 4-cylinder turbo engine from DTM as the range extender, since it only weighs 85 kg, it's pretty compact, and has a power output of around 450 kW. For the Dakar, they detuned it to only 200 kW, moved the turbocharger from the back to the side for better packaging, and mounted it transversely behind the greenhouse. Instead of revving up to 9,500 RPM, it now only runs between 4,500 and 6,000 RPM and is optimized for efficiency in that range. Now let's go through the drivetrain. Audi claims a specific fuel consumption of less than 200 gram per kilowatt hour. That is 5 kilowatt hours per kilogram of fuel. Since petrol contains 41 megajoule per kilogram or 11.4 kilowatt hours per kilogram, we can figure out that this engine's efficiency is at around 44%. That's a great number for a combustion engine and could be possible too, since this engine only runs in a certain condition and is especially optimized for that. If we assume that they would need an average power output of 150 kilowatt during a day, that would mean they need 30 kilogram or 43 liter per hour. This means that the fuel tank would be enough for 7 hours of driving. Now let's have a look at the efficiencies of this drivetrain. The fuel tank can hold 295 liter, which is equivalent to 2,352 kilowatt hours. The engine has 44% of efficiency, so we can get 1,032 kilowatt hours at the crankshaft. Let's use a conservative efficiency for the generator and electric motors of 95%. So we end up with 980 kilowatt hours for charging the battery. But also here are some losses involved, and 931 kilowatt hours are stored in the battery. If we then discharge the battery, 885 kilowatt hours reach the electric motors and 841 kilowatt hours reach the wheel. All in all, that gives us an efficiency of 35.8%. But it's also possible to bypass the battery and to drive the electric motors directly. This saves the losses in the battery and gives an overall efficiency of 39.6%. Another advantage of this drivetrain is that braking energy can be used to recharge the battery. If we think about cooling, we see that this car will need a high temperature water cycle for the ICE engine, a low temperature water cycle for the electric motors and battery, an intercooler, and an air conditioning system for the cockpit. Now let's take a closer look at the packaging. Audi used a steel tube frame and packaged the radiators at the back. We can see the water radiator on the left and the air-to-air intercooler on the right. They are fed through the massive roof scoop. The smaller section in the middle is the engine air intake. We can see the round air filter below the scoop, and its shape is especially good for the fine desert sand. Underneath sits the 4-cylinder engine with the generator unit on the left-hand side. The fuel tank sits between engine and driver's seats. The 50 kWh battery is mounted underneath the cockpit. Very interesting is the package in front with the 2 angled radiators above the electric motor. The rectangular front intake blends into a triangular shape, and the air can flow through the low temperature water radiators either side. Additionally, there is a fan on each side to guide the air to the side. The exit is hidden behind the wheel arch. Now let's have a closer look at aerodynamics. Important for off-road vehicles are small overhangs. The result is a very open front wheel arch where air can flow into the car. Important is then to make sure that this air can exit the car again, otherwise it acts like a parachute and drag will increase significantly. Audi solved this very nicely with the front intake sitting at the stagnation point at the front where they have the highest pressure. The huge amounts of air that flow through the wheel arches can exit at the side and flow around the spare wheels. Important for off-road and endurance race cars is to keep essential areas like the windscreen and side windows clean. Audi reached that with a strong sideline to keep the dirty front wheel wake below and to keep the upper side clean. That's also the reason why the important air intakes are at the highest point of the car. Additionally, driving through deep water is possible, so the car's air intake should be as high as possible. One very nice feature is that the high pressure in the gap between roof duct and car roof is used as air intake for the rear damper cooling. The front dampers don't need a cooling duct because there's a lot of air flowing along them anyway. Currently, we cannot see any function for the rear air intakes. The car also has a shark fin for higher speed stability, a flat underbody and a small diffuser. In summary, the new Audi RS Q e-tron is a prime example for a car in a new category that was designed in a short time from scratch. There are many nice design features and the exterior is functional and nice to look at the same time. So what do you think about the new Audi race car? Let me know in the comments below.